Now, when this worksheet was created, there is something called factoring completely, which we're going to learn a little bit later. All right, so on this worksheet, there are some problems that, hey, I need you to listen now. There's some problems on here that I don't want you to do. All right, so if you look up, the ones that I did that are on the worksheet right now is the one I did with the last class, so we're going to skip around a little bit. All right, but what I want you to do is I want you to take a look at the problems that I don't want you to do. All right, now how do you highlight them? You remember you take your marker and you turn it to white, and then you just delete them. All right, and the ones I want you to delete, here we go. And if you make your marker big, right, then you can just do one quick swipe and it's off. Everybody with me? All right, so the ones I don't want you to do are 11, 13, 18, 20, 22 and 23, 31, 35 and 36, 41, 43, 53, 58, 64, 72, 81, 83, and 85. Does anybody need anything repeated? So just look up on the board. It's right there on the board. Are you having trouble figuring out which ones I crossed out? All right, give you about 30 more seconds, and then we're going to start. All right. Now what I want you to do is this. I just want you to listen to me real quick. Eyes up. All you got to do is listen. You don't have to write anything. I'm trying to show you the patterns today of why things work the way they do. Please look up. All right, now, if I ask you to multiply, for example, 2x minus 3 times 2x plus 3, what happens to the middle term? Does everybody agree with that? It cancels because remember when we do the smiley face, that's negative 6 and positive 6. So the middle term cancels out, correct? Now, if I multiply 2x times 2x, I get what? 4x squared. This 4x squared is called a perfect square. Why is it called a perfect square? Because you're multiplying the same thing together. 2x times 2x is 4x squared. Now keep in mind the perfect squares. 1 is a perfect square because 1 times 1 is 1. 4 is a perfect square because 2 times 2 is 4. 9 is a perfect square. 16, 25, 36, 49, 64, 81, 100, right? 121, 144, 169, 196, 225. How did I know those so fast? Because it's just 1 squared, 2 squared, 3 squared, 4 squared, all the way up to 15 squared. Anybody have any questions? So any number that multiplies by itself creates a perfect square. This answer right here, if I multiply negative 3 times positive 3, is negative 9. This type of a problem is called the difference of squares. Why do you think they call it difference of squares? Because difference means what? Subtracting perfect squares. That's what that means. Is everybody with me? Now, if I said to you, come on, look up. If I said to you, factor 4x squared minus 9, you should be able to do that quickly. This only works when there are two terms. This only works when there are two terms. So it would have to be what? Two sets of parentheses, 2x, 2x, plus 3, and minus 3. That's how easy it is to factor. All right, let me give you another example. Let's say I said 81x squared minus 25. Everybody should be able to tell me, well, that's just factors to this. Tell me.
9x, parentheses 9x plus 5, and then parentheses 9x minus 5.
Beautiful. That's how simple it is to factor the difference of squares. If I said this, keep paying attention. If I said 49x squared plus 81, can I factor that? No. The reason why you cannot factor it is because it's not what? It's not subtraction. Everybody hear me? All right, now if I ask you this, if I said 7x squared minus 25, can I factor that? No, because 7 what? 7 is not a perfect square. Everybody with me? All right? Now that you paid attention, what I'm going to do is I'm going to randomly go down the first column, and you're going to tell me what the answers are. All right? Now I'm going to skip some on purpose because we have another pattern that I have to show you. All right? So for example, everybody take a look at number 7. What would 9x squared minus 4 factor to? Tell me, Gavin.
3x minus 2, 3x plus 2.
Yeah. Does it matter if I put 3x plus 2 and 3x minus 2? No. The order of the plus and minus don't matter. All right? Anybody have any questions? All right, so now help me out with number 16, somebody. Harrison, what?
That would be 9a and then plus.
Yep, and look how simple that is. Anybody have any questions? All right, so now 25. Somebody help me with that. Go. And? Exactly. All right, Ava, tell me about 34. Good. You guys, does everybody see? I don't need to go any further than that. Everybody agree? Simple, simple, simple. And how do I know that? Because there are how many terms? 2 terms, right? 2 terms. All right. Now the next thing I want to show you is this. All right. The next thing we worked on last week was if I said something like x minus 2 squared. This is considered a perfect square because, like, if I said 4 squared, I know that's going to be a perfect square because I'm squaring something, correct? So if I to square this, that'd be x squared minus 4x plus 4. Does everybody agree with that? Now, how do I recognize, listen to me, this is the hard part, so you just got to pay attention. Give me 5 minutes, pay attention, it'll be super easy. That is considered a perfect square. Why is that considered a perfect square? Because if I ask you to factor it, it would factor into x and x, minus 2 and minus 2. Does everybody see that? Now again, the middle term is what? Negative 2x and negative 2x, which makes what? Negative 4x. The negative 2 times the negative 2 is that positive 4 and x times x. Now, a good math student would not leave it as x minus 2 times x minus 2. They would just rewrite it as what? X minus 2 squared. All right, so I argued with somebody last class. They said, well, can I just leave it like that? I don't care, I said. If you leave it like that, I'm trying to make you a great math student. A great math student would write it as x minus 2 squared. I'm not marking something wrong if you put x minus 2 times x minus 2. I just know you're not listening to me. All right, now how did I know? Again, that was a perfect square. Here's the key. One last time, pay attention. This is considered a perfect square, and this is considered a perfect square, and there's a middle term. So that's your clue that it's going to be a perfect square. All right, so let me give you another example. So let's say I said 4x squared, and then I did minus, oh, I don't want to do that, 40x, I'll do a plus this time, plus 25. Uh-oh, that'd be, I'm sorry, this would be 20, not So what does that factor to?
2x plus 5 and
2x. There you go. That's the answer. Now look again. 2x times 2x is that 4x squared, right? Positive 5 times positive 5 is positive 25. 10x makes what? 20x. So your answer is technically 2x plus 5 squared. Does everybody agree with that? No problems. All right, so now let's just do a couple examples just to make sure you're good. So let's take a look here at number, well, we just did number 10, which is kind of weird. So that would be, again, 2x minus 5 squared. Now let's talk about 19. Somebody tell me about 19. Who? Hold on. Mr. Osborne, go.
Alright, so that would be
And? Exactly. So then just write, yeah, there you go. B plus 2 squared. All right, Isabel, tell me about 28. Yep. 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 That's exactly right. So some of you guys are getting pretty smart. We can just do x minus 8 squared. I'm fine with that. X minus 8 squared. All right, let's look at 37. All right. 37. Kim.
3n plus 2 and 3n plus 2.
Yeah, I'm happy with that. All right, let's do 40. Virginia, what's 40? Do you remember what times what's 121? Now here's how you remember that. 10 times 10 is 100. So it's got to be close to 10. There you go. 11 times 11. So it'd be what? Yes, minus and plus. Perfect. X minus 11, x plus 11. All right, Carson, help me out with 46. Good. Good. Perfect. Perfect. Emily, tell me about 49.
So it's 2 parentheses y plus
Mm-hmm.
4.
That's right.
And then it's
Yes. Good job. Y plus 4 squared. All right, does anybody have any? Now what I want you to do is, I want you to look at the worksheet and see if there's one on there you're going, I'm not sure I would know how to do that one. Which one? Let's look at 37. What's wrong with that? Can you see if I asked you about this? 3n plus 2 times 3n plus 2. 3n times 3n is 9n squared. Positive 2 times positive 2 is positive 4. 6 plus 6 is 12. Right? What?
You do number 52.
Let's look at 52. Two x and 2x. Most people can't do this because they don't know what times what's 225. 15. That's right. So it'll be 15 minus 2x minus 15 squared. Agreed? What?
64.
All right, let's look at 64. 64. Somebody else. Tell me. Let's look at 57. Yeah, a lot of people don't know what perfect square. 17 times 17 is 289. You hear me now? Okay, guys, listen. This really is like a 5-minute ordeal. If you understand the patterns, it's really simple. Do you agree? All right, so go ahead and finish that up right now. That's your homework.
How do you know when it's like 10 plus 17 and minus 17?
If there's a middle term missing, it's plus and minus.
Oh, but if there is a middle term,
They're both the same. Either both positive or both negative. You hear me?
this whole page.
Yep, the whole page. Knock it out quickly. I had several people get all done last time, so it's not really that big a deal.
Mr. Stroud.